Good morning, everyone. This video is presented to you by BACS 2B Group Number 2, and in this video, I'm going to discuss our chosen topic in programming language, which is MATLAB. MATLAB, an abbreviation for Matrix Laboratory, is a proprietary multi-paradigm programming language and numeric computing environment developed by MathWorks. MATLAB allows matrix manipulations, plotting of functions and data, implementation of algorithms, creation of user interfaces, and interfacing with programs written in other languages. Although MATLAB is intended primarily for numeric computing, an optional toolbox uses MuPad symbolic engine, allowing access to symbolic computing abilities. An additional package, Simulink, adds graphical multi-domain simulation and model-based design for dynamic and embedded systems. As of 2020, MATLAB has more than 4 million users worldwide, and MATLAB users come from various backgrounds of engineering, science, and economics. History. MATLAB was first invented by mathematician and computer programmer Clive Muller in 1960s. The idea for MATLAB was based on his 1960s PhD thesis, and Muller became a math professor at the University of New Mexico and started developing MATLAB for his students for a hobby. The first early version of MATLAB was completed in the late 1970s, and the software was first disclosed to the public in February 1979 at the Naval Postgraduate School in California. Early versions of MATLAB were simple matrix calculators with 71 predefined functions. At the time, MATLAB was distributed for free to universities. Muller would leave copies to the universities he visited, and the software developed a strong following in the math departments of university campuses. In 1980, Clive Muller met John N. Little, and they decided to reprogram MATLAB into C and market it for the IBM desktops that were replacing mainframe computers at that time. John N. Little and programmer Steve Bangert reprogrammed MATLAB in C, created the MATLAB programming language, and developed features for toolboxes. MATLAB was first released in 1984 at the Automatic Control Conference in Las Vegas, USA. MathWorks, Inc. was founded to develop the software, and the MATLAB programming language was released. The first MATLAB sale was following year when Nick Threfeten from the Massachusetts Institute of Technology bought 10 copies. Over time, MATLAB was rewritten for early operating systems created by Digital Equipment Corporation, VAX, Sun Microsystems, and for Unix PCs. Version 3 was released in 1987. The first MATLAB compiler was developed by Stephen C. Johnson in the 1990s, and in 2000, MathWorks added a Fortran-based library for linear algebra in MATLAB 6, replacing the software's original LinPack and AcePack subroutines that were in C. MATLAB's Parallel Computing Toolbox was released at the 2004 Supercomputing Conference, and support for graphics processing units was added into it in 2010. Advantages and disadvantages. Advantages of MATLAB. First, MATLAB is easy to use. The program can be used as a scratchpad to evaluate expressions typed at the command line, or it can be used to execute large pre-written programs. Applications may be written unchanged with a built-in integrated development environment and debugged with a MATLAB debugger. Because the language is so simple to use, it is optimal for the fast prototyping of new applications. Second is MATLAB is performance independent. MATLAB is supported on different computer systems, providing a considerable measure of platform independence. The language is provided on Windows 2000, Windows 2000, XP, Vista, Linux, various versions of Unix, and Macintosh. Applications written on any platform will run on the other entire platform, and information files written on any platform may be read apparently on any other platform. As a result, programs written in MATLAB can shift to new platforms when the needs of the user change. Third, MATLAB has predefined functions. MATLAB comes complete with a huge library of predefined functions that provides tested and pre-packaged solutions to many primary technical tasks. For example, suppose that we are writing a program that must evaluate the statistics associated with an input dataset. In most languages, we would need to write our subroutines or functions to implement calculations such as arithmetic mean, standard deviation, median, and so on. These hundreds of other advanced services are built right into the MATLAB language, making your job much more comfortable. Fourth, MATLAB has device-independent plotting. MATLAB has many basic plotting and imaging commands. The plots and pictures can be displayed on any graphical output device provided by the computer on which MATLAB is running. This facility makes MATLAB an outstanding tool for visualizing technical information. MATLAB has a graphical user interface. MATLAB contains a tool that allows programmer to interactively design a graphical user interface for his program. With this capability, the programmer can design refined data analysis programs that can be operated by relatively inexperienced users. MATLAB has a compiler. MATLAB's adaptability and platform independence are produced by compiling MATLAB applications into a machine-independent P code and then interpreting the P code instruction at runtime. This method is equivalent to that used by Microsoft's Visual Basic language. Unfortunately, the result applications can sometimes execute slowly because MATLAB code is interpreted rather than compiled. A separate MATLAB compiler is available. This compiler can compile MATLAB programs into a real executable that runs faster than the interpreted code. It is a great technique to convert a prototype MATLAB program into an executable suitable for sale and distribution to users. Disadvantages of MATLAB. First, MATLAB is an interpreted language. The first is that MATLAB is an interpreted language, so therefore may execute more slowly than compiled language. This problem can be checked by properly structuring the MATLAB program. Second is MATLAB is expensive. The full copy of MATLAB is 5 to 10 times more costly than conventional C or Fortran compiler. This comparatively high cost is more than offset by the decreased time necessary for an engineer or scientist to create a working program. So MATLAB is cost effective for businesses. However, it is too expensive for most individuals to consider purchasing. Fortunately, there is also an inexpensive student edition of MATLAB, which is an excellent tool for students wishing to learn the language. Known uses. Embedded systems. Embedded systems are computer systems consisting of hardware and software components and are designed to do a specific task. Some examples of embedded systems are washing machines, printers, automobiles, cameras, industrial machines, etc. With the push of one button, MATLAB allows us to generate a code that runs it on hardware. Controlled systems. Another most common reasons why the use of MATLAB is important is that it provides control to device and system. A control system is responsible for managing, giving commands, and regulating the behavior of other devices or systems. It is based on control loops. The devices or systems being controlled can range from simple home heaters to large industrial control systems that control the processes or the machines. Digital signal processing. Digital signal processing is the usage of digital processing such as by computers or specialized digital signal processors to perform a range of signal processing operations. Uses of MATLAB products make it easy to use signal processing techniques to analyze time series data and also provides unified workflow for the development of embedded systems with streaming applications. Wireless communications is a broad term for connecting two devices using a wireless signal. Teams in wireless engineering uses MATLAB to reduce development time, eliminate design problems early, and streamline testing and verification. Image processing and computer vision. Image processing is mainly focused on the processing of raw images and making them ready for other tasks such as computer vision. Computer vision, on the other hand, looks at the images like the human eye. It involves understanding and predicting the visual output. Algorithm building is vital for image processing and computer vision. Uses of MATLAB provides a comprehensive environment to analyze images and build algorithms. Internet of Things. Internet of Things is the network of devices, vehicles, and home appliances and other embedded with electronics, software, sensors, actuators, and connectivity with which enables the exchange of data. Uses of MATLAB help in the design, prototype, and deployment of IoT applications such as predictive maintenance, operations optimization, supervisory control, etc. FPGA design and co-design. MATLAB enables hardware-software co-design by providing C, C++, and HDL code generation which targeted support for programmable SoC devices. Mechatronics. Mechatronics is the technology combining electronics and mechanical engineering. Mechatronic systems require integrated mechanical, electrical control, and embedded software subsystems. Uses of MATLAB allows you to design and simulate all of this in a single environment. Test and measurement. Testing and measurement is the process in which electronic products are subjected to a range of tests, starting from physical tests to identify any physical defects to product-level functionality testing. Once you acquire the data, you can explore it and perform live visualization and data analysis. Computational biology and computational finance. Computational biology is the study of biological data for better understanding of biological systems and relationships. Computational finances is the computer science study of financial data and financial modeling. MATLAB helps by solving ordinary differential equations that model biological behavior. Also, the MATLAB Computational Finance Suite enables you to develop quantitative applications for risk management, investment management, insurance, and econometrics. Robotics. Robotics is an interdisciplinary field of science and engineering. It involves mechanical engineering, electronic engineering, and computer science, to name a few, to create robots or human-like machines. Robotics researchers and engineers use MATLAB to design and tune algorithms, model real-world systems, and automatically generate code, all from one software environment. Data analytics. Data analytics is the process of studying data in order to gain insights. It is mostly done with the help of other software and tools. Engineering and IT people are using MATLAB to build a big data analytics systems. Predictive maintenance. Predictive maintenance techniques are designed to determine the condition in-house equipment so that we can figure out when maintenance has to be done. The MATLAB Predictive Maintenance Toolbox provides tools for labeling data, designing condition indicators, and estimating the remaining useful RUL of a machine. Motor and power control. Motor control algorithms regulate speed and other performance characteristics. MATLAB algorithms help with energy efficiency, precision control, and system protection. It reduces the time and cost of algorithm development before you commit to expensive hardware testing. Last is deep learning. Deep learning is a broader family of machine learning. Uses of MATLAB is such that with just few simple lines of coding, one can build deep learning models without having to be an expert. References: https www.edukba.com, and second is from wikipedia.org. Members: Leader: Carmina Enopeña. Presenter: Kennette Felisilda. Researchers: Kennette Felisilda, Moses Becerro, Carmina Enopeña, and Jessa Duyog.